Okay, today we're looking at section 6.6, which is rational equations. Up until this point in chapter 6, we've been working with expressions, not equations. We've been simplifying, not solving. Today we're solving, which means we want to find the value of the variable that makes the equation true. Now this first problem is very similar to one that I did in the first week of class. And we noticed that there were two ways you could solve it. The goal here is to get x by itself. We could add a 1/6 to both sides. If you do that, well, it's easy here because it cancels out, leaving us with just x. Well, over on this side, we've got some extra work to do because we need to get a common denominator. In this case, it is 6. And I'm doing that pretty fast because I did do one just like this in the first week of class. So this is kind of old news. But I did this problem in two different ways. So let's rewrite it. We've got x minus 1/6 equals 2/3. We talked about the fact that instead of working with the fractions throughout, you can do what's called clearing fractions. And in order to do that, you find the LCD of all the fractions you see in the problem. In this case, that would be 6. It's an equation. You may multiply both sides of the equation by the same thing. So we're going to distribute the 6 through on the left where we have two terms. This gives us 6x. Oh, and 6 times 1/6, those 6's cancel. And here I can do some reducing. 3 goes into itself once and into 6 twice. So I get 6x minus 1 equals 4. And then we just continue working the problem, but now there are no longer any fractions in the problem. For my last step, I'll divide both sides by 6. My answer will be a fraction, but that's okay. You know, fractions are numbers. They can be answers to problems, and that's all right. So up until this point, you've had a choice. You could either keep the fractions and just work with them, or you could do what we call clear the fractions, which means to get rid of them so that steps in your problem don't involve fractions. But now that we're working with rational expressions, you're in a position where really you don't even want to work with fractions throughout the entire problem. You really need to use this method, which is clearing fractions. And no matter how big or complicated these equations get, this method still works. You find the LCD, you multiply both sides by that LCD, this clears the fractions, and you work the problem from there. So doing this example here, our LCD of 2, 4, and 8 is going to be 8. So I'm going to multiply both sides of the equation by an 8. Sorry, that's kind of long and stretched out, but it is an 8. Okay? What that gives us, well, let's see. On this side, 2 and 8 have a common factor of 2. So I'm left with 4 times 2n minus 3. I'll go ahead and distribute. That gives me 8n minus 12. And the fraction is gone. The 2 canceled out into the 8. Here, I'm going to multiply the 8 to both terms on this side. 8 times 3/4. Well, the 4 cancels with the 8. 4 goes into itself once and into 8 twice. So I get 2 times 3, which is 6. Be careful. This 8 did not become a 2. That was just some reducing that I did for this particular term. I still have to multiply the second term here by the 8. The 8's cancel, and we're left with n minus 4. At this point, notice that there are no fractions left, and we just go about doing our solving. I will simplify a little bit. Over on this side, we get 6 minus 4, which is 2. Let's maybe subtract the n from both sides. So we get that 7n minus 12 equals 2. We're not quite done yet, so let's bring it up over here. Okay, but this is just a linear equation. Let me copy it. 7n minus 12 equals 2. And we're trying to get n by itself. So let's add the 12 to both sides. We find that 7n is equal to 14. And then dividing both sides by 7, we get that n is equal to 2. And there's our answer. So this is kind of long, and it took a few steps. But after the first step, you no longer had any fractions involved at all. Okay, so moving on to our next problem. As I'm erasing, I'll just make the comment, keep in mind that you can always pause and you can always review. I'm going a little bit fast, just so that I have enough room on my memory card and my camera and enough battery to make these videotapes, but you guys can pause them wherever you want, review whenever you want. Example number 3 is 2 over 5 plus 2 over y equals 1. So this is our first example where we actually have a variable in the denominator. But here too, we look at the denominators, we say what's the smallest thing those both go into? Well, those both go into 5y. Notice this is a different process than when we were working with expressions. I'm not getting common denominators and then adding up fractions or subtracting fractions. I've got an equal sign. I can multiply both sides of an equation by the same thing, and that will allow the fractions to go away. So when we multiply and we distribute on this left-hand side, for the first term, the 5's cancel out, and I get 2 times y. For the second term, the y's cancel out, and I get 5 times 2, which is 10. And over on this side, I have 1 times 5y. Remember, you have to multiply both sides. Even though this side doesn't have any fractions in it, you still have to multiply both sides of the equation by the same thing. Now, what you have, pretend, you know what? Well, I wanted to erase it, but I'm not going to. But pretend this is just gone. You don't have any fractions left. And you just work the problem like you've known how to do since your pre-algebra class. You zero out. 10 equals 3y. To finish it off, we're going to divide both sides by 3. So the answer is that 10/3 is equal to y. There is one thing that you really have to look out for with these kinds of problems. You know, and this is also going back to our first week of class, you know that you can't have a 0 in the denominator. So in this case, if we had gotten y equals 0, we would have to say there's no solution. That didn't happen with this problem, but with another example that I give you, that is going to happen. So you've always got to take a look at your answer and say, if I plug that in up here, does that give me a 0 on the bottom? No, it doesn't in this case. We're good. So that's our answer. So example number 4 coming up. A little bit bigger. And this one is going to be 5 over n plus 2 equals 3 over n minus 2 minus 2n over n squared minus 4. This one is harder to just look at and see what our common denominator is. It is bigger. Don't let this factor intimidate or panic you. What you do is you just take a deep breath, you look at it, say, can I break any of them down and see what their factors are? And we can break down this difference of squares. And as I look at all the denominators, I see that I've got factors of n plus 2 and n minus 2. Those are all my factors for my denominators. So I'm going to multiply both sides of this equation by n plus 2 times n minus 2. And the thing that throws most people off is this. It's not that it's any different than the previous 3 examples we did. It's just that it's bigger and longer, and we can tend to lose track. So just keep pressing through, and don't let the fact that this is long intimidate you. That is our common denominator. And there should be a lot of canceling, because that's the whole point in using a common denominator. On the left-hand side, I am multiplying this by this fraction. If it helps you, you can stick a 1 underneath. Sometimes people just like to keep that top and bottom separate. You don't have to do it, but it might help. Here, the n plus 2's cancel out, and on the left-hand side, what remains is 5 times n minus 2. Moving over to the right-hand side, I need to distribute this to each term inside. When I multiply what I've written in blue by this first term written in black, the n minus 2's cancel out, and I get 3 times n plus 2, because these terms, or these factors, canceled out. So we have 3 times n plus 2 minus, now here, this entire denominator is actually the same as our LCD. When I multiply the LCD times this fraction, the entire denominator cancels out, and I'm left with just the 2n on the top. This is a difficult thing, and it's mostly because of this reason right here. So please rewatch this example as many times as you need to, maybe getting up and getting a drink of water or taking a deep breath in between. I know this isn't easy. But at this point, the fractions are gone. So look, this is something that you've been working with since the first or second week of class. So if you can kind of, settle down and be okay after doing this first step, then we just do this like normal. You distribute to simplify on both sides. Okay, and again, I'm doing this kind of quick because this goes back to first or second week of class. We can simplify on this side by putting the like terms together. And I'm going to subtract n from both sides. And I think I'll also just add 10 to both sides at the same time. As long as you do the same thing to both sides, you're good to go. So this is 4n, the 10's zero out. Over on this side, the n's zero out. We get 4n equals 16, where n equals 4, and that is our answer. Always, though, with this type of problem, you need to think, if I plug 4 in here, does that give me a 0? No. Does it give me a 0 on the bottom here? No. 4 minus 2 is 2. That's good. Does it give me a 0 here? No, because 4 squared is 16, and 16 minus 4 is 12. So we're good. We don't get 0 in any of the denominators if we plug in the answer we got. So we're going to accept that answer. I have one final example for you. So example number 5. Never forget that you can pause and go back. If this is going fast, that would be a really good strategy. So example number 5 is 1 over x plus 2 plus 2 over 3x minus 6 equals negative 4 over x squared minus 4. So again, we have this issue of, where do I want to put it? Big. It's big, and that causes many of us to want to panic. But what we do is we slow it down. We say, well, I can't break that down. Let's see if I can factor this and see what pieces it's made out of. Oh, we can break that down. This is x plus 2 times x minus 2. And then we look at each denominator and we say, what is our LCD? Well, in this case, all of the different factors we see, once we've broken these all the way down, are a 3, and an x plus 2, and an x minus 2, which I also see over here. So that's our LCD. It's pretty big. We're going to multiply both sides of this equation by this. So here we go. Here's the right-hand side of the equation. Multiply it by this. Here's the left-hand side of the equation. Multiply it by this. The whole side, no matter how big it is. You erase this to make some room. You've got it written in green on the left and on the right. And I think I'm going to start on the right-hand side because it's easier, I think. When I multiply what's in green by this fraction, the x plus 2 and the x minus 2 cancel out. I'm left with negative 4 times 3, which is negative 12. On this side, when I distribute, because I have two terms, they're separated by an addition symbol. For the first one, the x plus 2's cancel out, and I have 1 times what's left out front. 1 times 3 times x minus 2. Okay, so I have the 3 and the x minus 2 times 1, which is just itself. Plus, then I'm going to distribute the LCD to the second fraction. The second fraction has these two factors in the denominator, so this is going to cancel out with the 3 and the x minus 2. Right? This denominator here is 3 and x minus 2. Those would cancel each other. All that's left is x plus 2 times 2. Again, I'm sort of tempted to just erase all of this big stuff on the top of the board so that you can just focus on this piece. Because again, this goes back to week 1 or 2 of the semester, and we really should be solid with this. Let's distribute. We get 3x minus 6 plus 2x plus 4 equals negative 12. Combine like terms. We get minus 2. And let's add the 2 to both sides. 5x equals negative 10. Divide both sides by 5. So again, now at this point, we are just solving the way we did the first or second week of class. So our answer is negative 2. Remember though, we started out with fractions, so we need to make sure that we didn't cause anything to become 0 on the bottom. If we plug in a negative 2 right here, what happens? Negative 2 plus 2 is equal to 0. We are not allowed to have 0 on the bottom of a fraction, so actually after all this work, we have to throw out our answer and say that there is no solution. Another way to write that a little more briefly is to use this symbol. So after all this work, it turns out that this thing doesn't have a solution. I do have one final comment as we wind this one up. All of the equations that we've gotten, once we made the fractions go away, once we cleared them, we have ended up with linear equations where we're just doing the same thing to both sides. Sometimes, once you clear the fraction, you will have something where you've got a square on one of your x terms and you have a quadratic. If that happens, you're going to need to factor, and you need to do that. So I'm just giving you a heads up that sometimes when you clear, you end up with a linear equation like what we've seen so far, but sometimes the equation that pops out has an x squared in it. And if that happens, then you need to factor to solve. In that case, you'll typically get 2 answers, and you have to check both of them up here to make sure that neither one of them gives you a 0. Okay? Enjoy working with rational equations.